This is a pre-calculus. We're gonna study logarithmic function this video. What you did the previous video, we discussed about exponential functions. So exponential function looks like this one, guys. Exponential is f of x, b to the x. Base gonna be greater than 0, b can be 1. Now, we want to find the inverse function. How can find the inverse function pre-algebra class? We're going to put this one is y, b to the x. Then we're going to interchange x and y. That's going to be x equal b to the y. Now, how can find the y? How can solve for y? Then you're going to rewrite this one, guys. Remember, this one is y equal log bx. That's we're gonna define the log function. So here is very important concept. F of x is b to the x exponential function. This one is exponential function. We call this one is logarithmic function. This function is inverse relationship. So here's the definition of logarithmic function, guys. X and b gonna be positive real number. B can be 1. We already talked about it. B can be 1. B is greater than 0. Then we're going to say y equal log bx is going to be logarithmic function with the basis b, and we write it here. So what does it mean by this one? This one is inverse of exponential function. So we solve this one. Log with base b, the x, that's the logarithmic function. That's gonna definition of this logarithmic function is b to the y equal x. So left side logarithmic form, this one is exponential form, exactly same meaning, guys. So that's the how to define logarithmic function. Let's evaluate log function here. So f of x log 2 to the x, we wanna calculate log 232. That's we want to evaluate this function, guys. So how gonna evaluate this one? This definition is we previously say this one, you're gonna put this is y value. That's logarithmic form. Then you're gonna change this one is exponential form. 2, base is 2, y equals 32. So we are looking for an exponent, power. So 32 gonna be what? How many 2? You're gonna times it. 2 times 2 times 2 times 2 times 2. Here is the base is 2. This means 2 to the 5. Then you're gonna find y equal 5. So f of 32 equal 5. Second question is you're gonna plug in the 1 log 31. Same thing is y. This meaning is 3 to y equal 1. What is the power gonna be? That's gonna be y equals 0. So this value gonna be 0. Okay? So couple more, guys. Look at this. F of 2 log 4 and 2. This gonna be y value. Definition of this logarithmic form gonna be exponential form. 4 to the y equal to. So this one gonna be how can find 2 when you have 4 is base, y is exponent. This one is 4 to the square root. 4 square root of 4 gonna be 2. Another way you write this one, 4 to the 1.5. Right? That's the square root. So y gonna be 2. Y gonna be 1.5. All right. Here is you plug in the 1 over 100 log 10 1 over 100. That's gonna be y. So this is a logarithmic function. Let's change into the exponential form. 10 to the y 1 over 100. How can change this power of 10? So fraction is 100 negative 1. 100 10 square negative 1. Power is times 10 to the negative 2. So you're going to find y value is negative 2. That's evaluate log function is here. Let's just sketch graph of logarithmic function. So previous video we define log function from the inverse function of exponential function. That's the relation. Y equal log bx is inverse function of y equal b to the x. So when you see y equal log 2 to the x, base is 2, that's gonna be y equal 2 to the x. The relation between two functions is inverse relationship. So let's sketch based on this definition, guys. So I give the y equal 2 to the x graph. So here is a 1 and 1. Here is a 1 and 1. Guys, if you remember correctly from algebra class, here is 0 and 1, y-intercept. You're going to change this one is 1 and 0. Another way here is 1 and 2 right there, guys. Here is 1 and 2. You're gonna be here is 2 and 1. Here is this one is gonna be horizontal asymptote. Now this one changes the vertical asymptote. So vertical asymptote is x equals 0. Now you're gonna connect the point gonna be this way. That's the graph of y equal log 2 to the x. Guys, make sense? So that's the graph of logarithmic function. So you're gonna notice a couple of things we're gonna summarize later. How about this one? Let's just sketch the y equal 1 over 4x graph. What is base here, guys? Base gonna be 1 over 4, right? So inverse function of this logarithmic function gonna be y equal 1 over 4x. That's gonna be I sketch here. This one is y equal 1 over 4x. Now, we're gonna sketch the inverse of exponential function 1 over 4x graph right here, guys. So how gonna sketch it here? Let's plot the point here. Here is 0 and 1. Here is negative 1 and 4, right? And then here gonna be horizontal asymptote line. When you have inverse function, you have vertical asymptote right there. Vertical asymptote right there. Here is 0 and 1, 1 over 0. Here is negative 1 and 4, 4 and negative 1 right there. Then you're going to sketch this direction. So this one is y equal log 1 over 4x graph. Okay, so you're gonna see the characteristic of two logarithm function right here, guys. Let's just summarize the function graph right there, guys. Base gonna be greater than 1, that's increasing function. Base is greater than an increasing function. Base between the 0 and 1, decreasing function. Domain is very important in logarithmic function. Domain gonna be is 0 and infinity. Why? Domain is where this coming from, guys. Domain. This one is gonna be range of exponential function, okay? Range gonna be only a number. Range gonna be coming from domain of exponential function. So from the graph, you notice domain and range. Vertical asymptote is y-axis, that's the x equals 0. They pass through the x-intercept 1 and 0, guys. That's the characteristic of logarithmic function. Log function, there are two special logarithmic functions. First one is a common logarithmic function. What is common logarithmic function is gonna be base is 10. But what you write down common logarithmic function is you're not gonna put any base. You're gonna see no number in the base position. Then you're gonna say, oh, that's the base is 10. Another special log function is natural log function is gonna be ln x. What is ln mean here, guys? Ln is that space is natural base. So two very special log function. More popular one is natural log function is right there. How gonna sketch is ln x graph, guys? So this one is the inverse function of ln x gonna be y equal e to the x. We did the previous slide. So y equal e to the x graph right here, that's how to sketch it. Then you're gonna do exactly the same. We're gonna sketch y equal ln x. That's the inverse of exponential function. Next one is transformation. So I give the basic function is y equal log x. So what is this function means? It's a common log. So common log is I give it to you. Then we're gonna talking about transformation and domain of both function after sketching the graph. So what does this mean, guys? This one is go to the right 1 unit. So move this one. Here is a vertical asymptote line. Move to the right 1 unit. So this one move here, guys. Then this point move here. So we're gonna sketch this one. It's gonna be right here. That's gonna be g of x graph. So can you notice domain? What is domain gonna be changed here? Domain gonna be 1 and infinity. Vertical asymptote gonna be x equal 1. Can you notice? Go to the right. How about the move up and down, guys? What is this meaning? This one is parent function log. Parent function is log x, guys. Then move up, go up 2 units. So this whole thing move up. This one going to here, this one going to here. Here is vertical asymptote doesn't change. Everything move up here to move up 2. So looks like this. That one is gonna be h of x. Domain doesn't change, 0 and infinity. Vertical asymptote doesn't change, x equals 0. Okay, that's how to transformation of log function. But keep in mind, when you translate left and right, domain and vertical asymptote gonna be changed, guys. We use the graph to find the domain and vertical asymptote, but without graph, how can find the domain of log function? Here is the idea, guys. Y equal log b g of x. Anything is a form of here. Then we're gonna find the domain is g of x is greater than 0. That's we're gonna find all the x value. G of x gonna be greater than 0. Vertical asymptote, we solve the g of x equal equation. Then we're gonna find the vertical asymptote, okay? So for example, this log function, you really pay attention here, this one. So this one should be greater than 0. Let's just solve the inequality equation. So here is 2x greater than -4, x gonna be greater than -2. You see clearly number line -2. Here is -2 greater than 2 right here. So domain gonna be, you find -2 and infinity. Okay, that's you find the domain. What is vertical asymptote? You simply solve the equation. 2x plus 4 equals 0, 2x equals -4, x equals -2. That's gonna be vertical asymptote. Guys, make sense? Okay, one more. How about y equals ln x? So inside the parentheses, let's check the domain first. So 5 minus x gonna be greater than 0. Negative x gonna be greater than -5. When you have negative, divide by both sides, you change the inequality. That's x equal less than 5. Then here is a 5. X is less left side. Interval is gonna be -infinity and 5. Alright? What's vertical asymptote? Vertical asymptote, 5 minus x equals 0. 5 equal x. That's the vertical asymptote. Can you notice that this boundary gonna be This boundary gonna be vertical asymptote. Let's have practice question about finding domain and vertical asymptote for given log function, guys. This is h of x, ln x squared minus 9. We want to find the domain and vertical asymptote. Let's find the vertical asymptote first, guys. Vertical asymptote is going to be x squared minus 9 equals 0. This should be 0. So this one, x squared equals 9. Okay? Which meaning is x equals positive negative 3. Guys, make sense? Don't forget the positive negative. So you find the vertical asymptote. Here is going to be domain. Domain is going to be, this value is always positive, guys. So that's the domain. X squared minus 9 is greater than 0. Okay? So let's factor it. X minus 3, x plus 3 is greater than 0. If you forgot the factoring, a squared minus b squared, always a minus b, a plus b. Okay, that's you guys have factoring. So when you do the factoring, you have to find the interval. So this is 0, this is 0. You have to find the point 3, negative 3. Here is a 3. So this one is not equal. So here is a hole, here is a hole. Let's find which subinterval going to be satisfying this inequality. So you're going to plug in x equal negative 4 there. What happened? So negative 4, negative 3, negative 4, positive 3, negative 7, negative 1. That's going to be 7. It's greater than 0. Not here is greater than 0. That's right. That's you're going to take it. Next one, x equals 0, 0 minus 3, 0 plus 3. That's going to be negative 3, negative 3. That's the negative 9, less than 0. That's not satisfying this inequality. It's not. So x equals 4, 4 minus 3, 4 plus 3. This one is 1 times 7. That's going to be greater than 0. You're going to take it. So you have find the domain is negative infinity, negative 3. That's going to be 3 and infinity. That's the domain of this logarithmic function. Last part of this video is we're going to do application problem with log function, guys. This is very interesting equation. Students participating psychology experiment attended several lectures on a subject, took the exam. Every month for a year after exam, students took a lead test, see how much their material they remember. Of course, as time is go on, you guys keep forgetting. So they have this model, human memory, is right there. That's the logarithmic function. So t is the time in months. T equals 0 to 12 months. Then ft is modeled how much you're going to remember. What is the average score and the original exam? That's the first exam they're going to take it. So A going to be, you're going to t equals 0. So F0, 75 minus 6 ln 1. What is ln1, guys? ln1 is 0, right? So 75. That's the 75 score. But after 2 months, what happened? T equals 0, f of 2, 75 minus 6 ln 3. Guys, make sure you how to use the calculator, okay? So this one is almost 68.41. That's decreasing, right? After 6 months, what happened? How much are you going to remember? F of 6, 75 minus 6, ln 6 plus 1, 7. You're going to 63, 60. So 63, 60. As you expected, when your times go on, your test score is decreased.